Hello, Krakow. You'll have to excuse my voice. It might have been the weird factory you went to yesterday. It was very hipster, but my voice is a bit strange today. So I'm very lucky, but I'll try to be as clear as possible. Hi, I'm Sam. Feel free to, actually you can't even see my Twitter name there. But yeah, feel free to tweet me if you have questions, quotes, send abuse of me, it's fine. Today, I work at Just Eat. We basically provide a platform where people come in and order takeaway. So it's an aggregated view of all the restaurants, and you search through through whatever restaurant you want, and you make an order. So that's the context. I work in the engineering team, and tech lead in that work with BI. So quite heavily involved data. So the talk today is going to be about metrics, and the goal of metrics-driven development is to closely align the business and tech, which was what Agile was actually meant to do. We're going to talk about a lot of things. We're going to talk about events, commands, distributed system, because our platform is quite a distributed system. We're going to talk about CQRS, domain-driven design. Sam Elamin, I'm up there. I'm interesting to talk about. And if you feel like there's any buzzword that I might not have added, please give me a shout and I'll make sure to add it later. Oh yeah, DevOps, that's the one. Thank you. Definitely add it next. So, originally the goal was to align the business, right? You want to understand what tech you're working on and why you're building it. The why is actually quite important. And based on this, the first question you sort of ask yourself is, well, we use Scrum in my workplace. I know what I'm supposed to be doing. I know what value I'm supposed to deliver. That's really why we're all employed, right? We are in an industry that requires intelligent people, and we're employed to deliver value. And you're sort of like, well, why do we need this stuff you're talking about? Like, I'm able to talk in a stand-up and understand what people are working on, why we're building this particular thing. And that, in some sense, that's true, but I've worked in a lot of places where just knowing what your team's working on does not tell you why you're building this thing and what value you're producing for the company. Especially if you're working with marketing teams, they tend to come up with all sorts of feature requests that might not always make sense, but you end up having to build them anyways, and that's actually quite frustrating. You don't want to build something you don't believe in. You want to wake up at work and be excited about what you're doing. I'm lucky enough to be able to do that, and I'm sure quite a few people in the room are passionate about what they do, but sometimes working in Scrum doesn't actually tell you what value you're delivering, but also when you're so pressured to deliver something, it's sometimes not delivered ideally, and that's kind of what TDD was brought in to do, right? It was brought in to make things more stable, but also understand what this code's doing, understand what you're trying to deliver, and make it much more stable. But I've worked in places where I've come in and they've asked me to do stuff, and there's so many tests, right? It's fully test covered, but the tests don't actually reflect the language you're discussing with when someone. So, for example, a perfect example is recently a few years ago, I was tasked with implementing something to do with saved cards. So someone comes in, they want to pay for something with their card. And they save their cards with the business, and they wanted to do something with this saved card. And we sat there. We had like a Three Amigos approach, so understand the requirements, having a requirements gathering meeting, and then you go into the code, and it's completely different. So it took me a few tries of following the string to understand where customers actually pay, to realize that the code calls saved cards tokenized authorization service, and so on and so forth. So you end up working as a translator. You hear one language in the when you're speaking to the business, and then when you go and look at the code, you have to translate. And the reason it was done that way is because when they're working with the payment provider, that's the language the payment provider uses. If you want to pay, we call it a token. but the code then reflects another company's language rather than the actual company you're working on. So that was the same problem kind of migrated to BDD, where we're like, well, we're actually going to implement our business domain specific language, and if anyone asks us how this thing works, we'll just send them a couple of tests. That was the original goal, to try and use the organization's behavior and reflect it in the software you're actually delivering. But that didn't work out very well either, because when's the last time someone asked you how something works and you're like, well, here's a set of tests. If they're a developer, fair enough, but if they're not, they're going to be like, no, actually, I don't understand any of this mumbo jumbo. Just explain it to me in layman terms. So I need to stress that everything I'm talking about today is not a replacement for this. It works very, very well alongside this, and it's supposed to work with techniques like continuous integration, deploying faster. So it's not a replacement. But what exactly is it? It's knowing exactly what's happening in your platform at any given moment. Not only you're not there just to shift the software, you're there to know how long something's taken, you're there to know how hot a box is running, how well it's behaving in production, how the server's running really. And you know, traditionally, we'd have to look at this if you're on Windows, something else if you're on Linux, to try and understand how things are. And then if you're in the cloud, there are other providers like Amazon have CloudWatch, Azure have something similar, I think. But they basically tell you, okay, this particular CPU is running lower RAM, or it's running high on CPU, and it's going to go slow, so sort it out, basically. And traditionally, this was not really a developer's problem. You sort of say, well, that's operations. We're here to write the code, right? You deal with actually finding out why this box is running hot. It's not my problem. I shift the software. It worked fine in QA. That's it. It's over the wall. But the more and more we move towards DevOps, the more we realize that actually no, the engineers actually built this code. You have the greatest insight to how this thing works, understanding every single line. You're the ones that can say, this isn't working like because of this is working slow because of that. Maybe we're calling the database and this particular area is slow, which it's holding calls, so that's the reason why the memory is high in the box, and so on and so forth. So that's why engineers are the best placed people to operate these stuff in production. So when I first joined my company, I was completely not sold on the idea. I don't understand what the benefits are. So traditionally, when there's a problem in production, when you're in the mission control, basically, where we try to understand the impact, to the customer, how many people are affected, what's the impact to the business, how many orders are affected, and so on and so forth. And we'd sit in a room and trying to discuss and diagnose the situation to try and understand why it's happening. But we also found ourselves all the time logging into machines to look at the logs. And we had no insight into any sort of graphs. We'd all be talking in a room. Okay, I'll log into that box. I'll log into the box, and that was easier when you had only a few machines. But now that you're moving towards a distributed system and you've got hundreds of them, it's very, very difficult to RDP in a box. So that's one of the biggest highlights that I enjoyed. The fact that I don't actually have to RDP. We have one place where all the logs are shipped. We have great insight to try and understand the path of when the customer first hit the website, all the way to the point where they made an order or it was shipped. We've got logs for each and every of these microservices logged to one place, and then we have we use the ELK stack. I'll go into more details later in the demo, but you can search through that. Through Elasticsearch, and you sort of understand everything that's happening. But what's really important is, now, that was where I was coming from, but now when we have an issue in production, which we never do, right? But now what actually happens, we sit in a room and we're sharing graphs. We're sharing graphs to, what's the impact to the business, how many orders changed, and we have insight to how many orders were made a second. So to the actual second, you've got this is the number of orders per minute, or this is the orders per second, and this is how it's dropped after that particular deploy. And we share these graphs, so we focus on the actual problem. It just lets us focus on this is the exact problem, and we all have we make our decisions based on graphs, based on metrics to the business, and metrics are the value. So you're employed to, say, within a team that's focused on conversion, for example, and that's your metric, and you're focused on pushing for that. And when there's a problem in production, you're like, okay, let's focus on getting this problem resolved. So when you have these metrics in place, you have more freedom to experiment. You've got more freedom to try different things, and you're given immediate feedback into what change you made and how it affected the customer, or how it affected your end user. And that's really fulfilling, to know that you've developed this thing and you can see in real time people are using it, and how many people are using it, how many people have discovered this new feature that you've written. But also it gives you a lot more confidence about, it's working, because people are using it. So it gives you more freedom to try out new things, and really that's where you start innovating, because you're trying out new things that have not been tried before. And it really gives you more passion about what you're doing, because you believe in yourself more, basically. It gives you more confidence that you're able to fail faster. Failing's fine, but as long as you fail fast, not like 6 months or 3 months down the line, because not a lot of people can afford that sort of failure, other than Microsoft. So there are three main types of metrics that you have to look at. So the first one are the business metrics. Now, these are called counters, because you understand how many times it happened. So an occurrence, this happened once, logins are an occurrence, searches are an occurrence, orders are an occurrence, added an item or added to basket, that's a counter. So you keep incrementing them, and it goes up by 1 every single time. So that's the first type of, and these are the most important ones, because these are not just developer friendly, these are shared throughout the business. Whenever there's a new feature deployed, everyone's interested in that. Whenever there's a problem in the platform, again, everyone's, not just developers, QAs, stakeholders, people who work in customer service, they're all looking at these graphs. So you have, again, a full understanding of the impact to the business, and everyone's on the same page. The next type of metrics is the application metrics, which are how long something's taking. So you've got an API that a website depends on, and you get a call saying this is slow, and it's very vague, but they don't understand the problem. They're just saying, okay, trying to do this thing is slow. So you're like, okay, let's see how the impact to the business and to the customer. Is it worthwhile to look at this at this moment in time? Because it could be any time. Since you're an engineer and you built it, you're kind of on call for this stuff, and it's amazing how more attentive people can get when they're deploying stuff if they're on call for it and they have to wake up at 2 a.m. So when something's taking a while to run, you sort of say, okay, well, let's have a look at the API or the website or whatever component is responsible for doing this behavior, and how long it's taken to respond. And you've got a baseline to say, okay, a few days ago, this is how long it used to take. But now, after a particular deploy, or maybe after a spike, marketing did a campaign, and now we've got a spike that is higher than expected. This is how long it's taking. So now that you look at how long, this is ranges, so it could be a percentage. Sorry, they're not counters, they're seconds, how long something's taken. So the next is one more level deeper, which is our infrastructure. So that's the thing I was talking about earlier on, which is the CPU performance, the memory performance. So if something has affected the business, then because it's taking too long to respond, you sort of say, okay, why is that particular thing taking to respond? Maybe it's a blocking call, but maybe the box itself is just running too hot to be able to handle this sort of pressure. So you look at things like, and these are gauges. So X amount of percent or is free, or X amount of percent is being taken up. And these things are way at the lowest level, basically, to understand how this particular machine, whether it's a VM in Azure or just a VM in your own infrastructure or an EC2 instance in the AWS world, to tell you how this thing's behaving. And this can tell you, okay, maybe the short-term solution is to scale up till you investigate why it's happening, or maybe it was a deploy. All of this is just giving you insight, like immediate real-time insight into how your platform as a whole is operating. And these are actually quite useful. When I first joined, I was like, I'm never going to look at this. But you end up looking at it more and more and more, especially when you've got a higher volume than you expected. So if you look at what we're actually doing, we were just following the route of the cash. We're following the money. So we start off with the customer or end user trying to do something that is the value that you're providing, and you're following all the way down from an infrastructure perspective. They hit a page. They made an impact to the business, and then you look at the application, how long it's taken, and then you look at deep down to see the real reason it's taking too long. It might be something else, but these are the quick sanity checks that you go through. Now the business metrics are the ones, the counters are being shared across the business, but application and infrastructure are mostly developers or IT people. They have access to them. We don't really actually share them as much because people aren't interested in it. They were like, actually, just give me the impact to the actual business. So that's the one that everyone sees. While these are more developer friendly, I guess, because you can't be talking to a business person and say, actually, this was because the servers were running at 95%, because they don't really care. They just want it fixed. So you sort of you're like, well, okay, that sounds good. We sort of understand the three different type of metrics, but how do we implement it in our company, right? Because our company is completely different than everyone else. How can we actually implement it? And the answer is you can't do it as a company whole, right? You can't convince an entire company to change the culture unless you're the CTO, for example, and even that takes time. So my advice has always been focus really, really small. Focus on just your team, the 2 or 3 or 4 or 5, 6 people in your team, and you're like, okay, what are we employed to do? What is our goal for today, or the goal for this week, or the goal for this sprint, or the goal for this project? Define it. Define a metric. Stick it on a board somewhere, and say, okay, this is actually the most important thing. And what that does is it's amazing, because it focuses all conversation on just delivering that. It takes away all the bullshit of the politics. Actually, I want this because this is important. You're like, okay, let's go back to how does it help us get there? And it just focuses the conversation, and it's powerful. You've got so many people in teams to drive for that one goal. It focuses the conversation, and it helps you deliver faster. So you assign one metric. So, for example, in the team that I was in about the saved cards, our focus is payments. Make payments easier. Make payments faster. And it could be still a vague goal to start off with, because you're not quite sure what your goal is. But at least give it a name, and then you iterate over it. It's okay to fail. It's okay if you don't know what it is, because we're in IT. We fail all the time. Like, the motto for a very long time was fail fast. And you will probably get it wrong the first time, but you have to accept that and be fine with it. But as long as you give it a name, and say, okay, we're going to focus all our conversation on this one thing, it's quite amazing what you can achieve. Then you start collecting metrics on this one thing, this really small thing. It might be small, but it's the most important thing to you. And you start collecting metrics. How many times it happened? What are the components that it's affected? Start off with how many times it happened, because that's the most important one. And then you start looking at, okay, this feature that you've built, or this project that you've built, the most important thing that's happened, how many times have happened? And then you start gaining more insight into how your business users are using this thing you're actually working on. So if your team is based on conversion and someone comes in and says, okay, you know what, we want people to sign in via social media like Facebook or Twitter because it improves conversion. And you're like, well, does it? Let's do the smallest amount of work to prove it. Because again, in IT, all we do is assumptions, right? We're not 100% sure of anything. We assume that if we do this, then we'll get this. If we do A, we'll get B. It's assumptions. So Goico has impact mapping, and it's very powerful in this. Do the least amount of work to prove that you're going the right way. Do the least amount of work to continue proving the hypothesis. So if you fail and you go off course, then it's fine. You've done very, very little and your risk is small. It's the same with deployments. You deploy small because you want to be safe. So yes, you start collecting this one metric that you've assigned to your team, and the way it works is actually quite simple. We use StatsD, which is just a Graphite StatsD server that we push metrics to. And it's just in the payments example I was telling you about, you've just got, you define what it is. So the tenant there, which is a country, but you can call it whatever you want. And it just says, okay, that's a gauge of, the CPU is at 47. And you can get that from cloud providers easier, but if you want to do it your own, you can do it. The timer, how long something's taken. These are the application metrics. And then the counter, which is the most important one. There was this many attempts. You can do attempts, successes, but you can also do failed. But really, if you've got attempts and you've got successes, you've also got the failure. And then it's just literally a UDP client to say, fire it off. And it's you don't wait for an acknowledgement. If you lose some of these, it's fine, because it's everything. Every time something happens, you don't want to wait for an acknowledgement because you don't want it to affect your performance of the platform. So it's a fire and forget. This has happened. An occurrence has happened. It's an event. This has happened once. This has happened. It's taken this long, and this is the state of play in where I am. And that's the gauge of the infrastructure metrics. And it's just literally send it to a host name or address. You can get Docker images if you want, or you can get a pre-prepared AMIs if you're in the Amazon world, and it will just give you a DNS entry or an IP address to say, okay, now send all your stuff over to this one box, and it will just start creating buckets, which are, that for example is buckets. A payment attempt is a bucket, and you, in this scenario, it's an attempt to pay with saved cards or attempt to pay for a particular thing. But whatever you're working on, you define that metric, and then you have to create a bucket for it. So the most important thing is you will get it right get it wrong the first time. So don't measure everything. Just measure that one thing, the most important thing, and then that in itself will have to prove itself, in the sense of, you don't just apply the whole do the least amount of work to prove for just a business. Do it for this as well. Maybe this doesn't apply to you, but prove that it does, and just don't take it as faith. And it's very important when you go to a conference and you come back and say, okay, this is the right way. Let's actually prove that it works for us. Again, it's an assumption. It's fairly simple. Like, okay, it seems like a good idea to measure this value that we're delivering, but just do the least amount of work possible to see if there's value. That way you can then convince other people and say, well, actually, we've delivered this project, we've delivered this feature, and we had amazing insight into what the customers were doing because of this this method of looking at our metrics. And then people will be convinced when they see results. So yeah, it's very important not to measure everything. You get quite drunk in power when you say, okay, I can see everything. Let's just measure every single thing. And worry about what's important, what's not. If you focus really small, you'll invariably achieve better results. But now that you've defined this sort of metric and you've started collecting information on it, any future decisions should be based on this metric. Any future work should be based on this metric, because you're all in agreement that we all agree this is the most important thing we're doing. So any future decisions, any meetings that you're having about what we're going to do next should always come back to the one true goal that you're all employed to do for that amount of time, whether it's a sprint or a month or a project. And that really helps. Even if you're not working with just engineers, if you're working with other parts of your business and they're asking for something, it helps focus on delivering the most amount of value that you possibly can when you're focused and you define what metric you're working on. A few useful techniques that we had to learn the hard way. I think it's very important to talk about, what failed and what didn't, and not just to give you the nice parts. We feature toggle, and we learned very, very quickly feature toggling is sort of like some sort of safety net. We used to do a feature, we'd deploy it, we'd have a metric assigned to it, and it just didn't work. So we basically start feature toggling stuff. And the way it works is you do a canary or a dark release. Let's say in that example of allowing people to log in via Facebook or Twitter or any social network, you switch it off at first, and then you phase the deployment to like 5% or 10% or 20 or 30 or 40, and you're continually getting more and more confidence this thing is being used in production. Maybe you give it internally to staff first and you say, go on and try. And over the time, you're reducing the risk. And it's very powerful to have these phased deployments, because by the time marketing sends out and say, we've just done this massive project, or we've just added this amazing feature, you're already confident because it's already been used in production for months. You're already confident this is going to work. And you've got metrics to look at how it works and how users behave in it. So it's actually very, very powerful. Alerts. So what I was saying about developers who are on call now, when you've got these metrics, you start understanding the overall behavior of your customer, and you start setting up alerts when you think the behavior is wrong. And really, alerts are just tests that are continually running in production. So if you've got alert on people who can't log in, or people can't buy, or people can't search, this alert is continually running, checking the metrics, checking the stats to say, okay, have we got logins? Have we got searches? And if it dramatically falls to below what you expect, it sends out an alert to say this test has failed. People can't do what they're supposed to be able to do, and it notifies whoever's on call to have a look. Maybe it's so. For example, in the payments project I was working on, we understood that it's always 60 to 40 about the percentage. You've got 60% people who pay by cards, 40 who pay by cash. And then suddenly we had, 70-30 for cash versus card. And that's an unusual behavior. So we sent out an alert to say, there's something happening here. We're not quite sure if it's important or not, but it's something you should know, because it's different than the usual behavior that we have. So in that case, it might say, okay, your dependencies or your payment provider is not accepting as many as they used to be. Or it could be just, there was a promotion and people prefer the other types of payments. But either way, it tells you that there's a deviation to the usual customer behavior, and it's something that you should probably look into. And that really was extremely powerful when we're working with people who are in customer services, because we were not just reactive anymore. We'd have the graphs, we'd have the alerts, and they don't have to come to us and say, this thing happened. And I remember having a conversation with a supervisor in the customer service team, and said the moment we had faith in the IT team was because when we came to you and said there's a problem, we told them we're already aware of the problem, and this graph we shared with you weeks ago tells you how we found out and how long we might be able to take it, and you'll still be able to see from this dashboard when it's fixed. So we have a single source of truth, the ELK stack that I'll talk about. So that's Elasticsearch, Logstash, and Kibana. Kibana is just a dashboard I'll show you in a while. So we ship all our logs to Logstash, and Elasticsearch lets us search through it. When we identify a problem, we tend to say, okay, how many users were affected? If it's a large number of users, okay, fine, give us an example of an order ID or an email address, and we'll try to understand the flow of the journey and where it died off. But if it's 1 or 2 users, we get about 3,000 or 4,000 orders a minute. So we're like, okay, this doesn't signify something that we should investigate at 8 or 9 p.m. in the evening. So we've got the single source of truth that everyone looks into. Everyone has the same information. So they aren't. There's no that lack of communication because we're constantly posting this information in the rooms that we're talking in, because of that single source of truth, everyone has a high visibility of what's happening. You've got real deep insight into your customer behavior and understanding exactly what they do and what the problem is. And you'll never be in a situation where you're actually, I don't know how my team impacts customer behavior, or how this feature that we deployed months ago, how is it being used? Or is it actually being useful? Or is it just something, marketing decided to come up with and it's actually not useful at all? So when you share these graphs with everyone in your organization, you really they start seeing the trends and the behavior. Then it's very easy for them to pick out, what's wrong or what can be improved on, or a good idea, because everyone has a good understanding of how your business behave, and understanding what you're actually delivering, what value you're adding is the route to success, to understand being even better. And the core of that is understanding the data and understanding how your customers behave in your platform. And options, right? This is something I've learned over a while, that sometimes things happen, and you have issues in production, and whenever you're in the war room and trying to organize, you've got like your boss's boss behind you, sitting behind your back. It's a very stressful situation. But what I learned is they aren't expecting you to solve the problem immediately. They'd like that, but the most important aspect is giving them options. These graphs, these dashboards give them options to identify the impact, how many people are affected, and let's have options, because with feature toggling, what are our options? They want to know what their options are. So there was an issue with the saved card stuff. Not something I wrote, obviously, but there was an issue where the payment provider was not able to accept as many, and it was a rubbish user experience for the customer, because we knew they couldn't pay, and yet we still gave them the option. So we said, well, okay, let's just disable the saved card service, so people can pay with signing up a new card, or they can pay by cash, but we'll disable the saved card service. That's an option. We can disable that. It's a bit rubbish if you come in and you're a constant user and you look at it and it's actually, I used to be able to just pay with the card that I've already saved, now I have to input it. That's still a lot better than giving you an option that we know is going to fail, and you're like, actually, I hate this website, because why are they giving me an option that I can't use? And that's really frustrating. I think us as developers, we notice these things, but perhaps the non-tech savvy customers, they still find it annoying. They perhaps might not know why they find it annoying, but it's still annoying to them. And they lose faith. And your reputation is all that stops you from going completely bankrupt. Another technique that we employ, which really surprised me so much, was we run fake load in production. So we quickly learned that we have to deal with scale. We were growing far too much, so we didn't know. We weren't sure that our systems can handle that particular scale. So we ran 50% more than we expected that night as fake load through production going into the production database, and that just shocked me. But this is a safety net to say we are always confident we can handle the scale in 3 months' time. So it was basically a time machine, because all business or people in sales have forecasts. They say, okay, if we do this, we forecast we're going to have X amount of growth. But traditionally, IT teams don't have these forecasts. They don't have these vision meetings where they say the business expects to be in we're in position A, and the business expects to be in position B in 3 months' time. Can our platform handle it? They're not going to use a different platform. They're going to use yours, and you sort of ask yourself, can it handle it? So we run fake load through it to say, okay, in 3 months' time we'll be handling 50% more. Let's prove it today. And it's all about proving that you can scale. And it's really powerful because when you have an issue, you kill fake load, and instantly you have 50% more capacity. It gives you more breathing room. And we use JMeter for these scripts to just run the same HTTP calls that we got through our normal customer behavior. So now it's the demo time. So feel free. I'm going to show you the graphs of the different sort of metrics. I'm just wondering if that's going to work. So we've got this. This is Kibana, which is showing you exactly all the logs of what's happening and how many times something happens, and it's exactly the entire log file. But you can also start looking at the messages, the URL they came from, the order ID. These are specifically the single source of truth that was, but these aren't the metrics or the dashboards I was talking about. The actual metrics is here. So you start looking at certain times, and this is Grafana, which is looking at our StatsD server, and you start looking at over time how many orders you had, how many these are business metrics at the start at the top, how many orders you've had at a particular time. You can start defining them or putting in time ranges. Then you've got new cards, for example, and these are again business metrics because they're counters. Then we've got the API timings, which are application metrics, how long something's taken. And then finally, you've got things like how many exceptions you've had, and again, all this is still application metrics. So I can pop into, let's have a look if we can get you some infrastructure metrics. Instance healths. So this tells you things like, the health of the machine, the health of the box, and again, these aren't quite shared with the business as much as the others because they're not really that interested on the health of the box. They're more interested in the health of the platform. So yeah, that is actually the entirety of the talk. Feel free to ask questions if you've got some. Go on.
So what's the relation between Grafana and Elasticsearch, so the StatsD and Elasticsearch?
So the question was, what's the relation between StatsD and Grafana and the graphs or the dashboards and the Kibana dashboards? They are used interchangeably. You can create dashboards in Kibana, but really, when we're looking at trends or behaviors, we're looking at Grafana to look at how the overall platform's going. And then when we identify a problem, that's when we go to Kibana to say, give us an example of a problem and let's look at what exactly happened. So it's more detailed or more to that one order lifecycle or journey, and we go through the logs. You can, yeah. Once you get an example of we've seen a problem or we've seen a break in the trend or the behavior, fine, let's identify one, and that's when we look at the logs, and that's when we look at Kibana. And then, but you can also look at, because it's logs in Kibana, you can create dashboards of how many errors have been happening. That's still used, that you can still use Grafana for it, but it can tell you there's been 100 errors in the past minute, and then you'll still get an alert from the other platform. But we're very autonomous in our teams, so you can use whatever you want, and you're also sort of encouraged to create your own dashboards and share them, because the more data we have, the more insight we have. Yeah.
Is there any architectural style that is friendly to having metrics in your code?
Well, the question was, is there any architectural styles that is beneficial to gathering metrics? No, because it comes back to what your platform or what your business is delivering. So you could implement these clients because they come in any language, these UDP and TCP clients, because you're just pushing packets. But obviously, when you segregate the components, then it's easier, because then you can have a skeleton that's already used. It's already pushing these stats, and then every time you build a new feature, you use this skeleton API or skeleton component. Even though that's called microservices, I try to avoid to use that term. But yeah, there isn't. Although that's easier to do, but there's no like strong definitions actually, because you're using everything in one box. You've got this monolithic thing. You can't use this because it comes down to what value you're delivering, and the value you're delivering is going to have to be in the code, right? Because the business is doing something. So you can just use decorators, for example, to say, okay, every time this happens, because it's happening in the code, send a metric. Yeah. Okay. Okay. Yeah. So. Yeah.
Some applications might be related to the counters, like faults and so on.
Yeah.
So why do you prefer this way of?
So the question was, some businesses have KPIs, key performance indicators, to say you've got X amount of faults that have happened, or how long something's taken. So how long someone takes to search, or how long something takes to pay. So businesses have that well definition, like it shouldn't take X amount of seconds to do a search, or X amount of seconds to pay, more than that. And that it's a metric on itself. These are just an overall, actually I should probably show you them rather than just a screen that says my name. These are just the base ones, because this isn't necessarily the best way to do it for your team, but these are a start of the best metrics you can employ if you've got none at all. But the fact that you've just defined a key performance indicator to say we have to have X amount of seconds or latency, or less than 10 faults a second, for example, that's a metric in itself. So that means you've already got that first step of you've defined a metric, let's start collecting them.
Okay, then the second question, if you have those dashboards in open source, for example, okay, in open source, so or maybe you have some useful links with ideas of
So the question was, do you have links on different dashboards? The dashboards themselves aren't open source. The tools that to create them are.
Not the tools, but the ones you use.
So I can send out links to Grafana and the ELK stack. But basically what we're doing is what Etsy are doing, which is like an auction company, and they use StatsD. But I can surely tweet links after the talk about where to go for Grafana and StatsD. But the servers themselves you find AMIs or images of them in any cloud provider.
Yeah, but I mean, these metrics, probably you use not the one metric, maybe you use some calculations for those metrics, so you just pick up one.
No, we don't use calculations. We keep counters, but in our company we know, like the questions of, okay, we know the behavior should be X amount of percent for cache, or X amount of percent for logins via normal login, and X amount of percent via Facebook or social. So we know these calculations. So maybe I'm misunderstanding the question.
No, that's okay. Thank you.
You're welcome. Any more? Yeah.
You said that you can use this approach to prove or disprove feature ideas.
Yeah.
How do you do it?
Well, whenever we get a feature idea, we're all in the team. We know what the metric that we're pushing is, so we all have a discussion on how this new idea will push it. And if we're unresolved to whether this will push it or not, that's when we do the least amount possible to see if it does or not. So sometimes you won't be able to prove that it doesn't push that idea. Sometimes you just have to do the work. So you do the least amount possible to prove it. Okay. Oh. No. This all is hosted with. Well, it's still hosted in Amazon, but it's us.
Just curious how, because you said that it works with payments, so doesn't it violate the PCI standard?
No, because we don't. So the question was, doesn't this data violate PCI? No, because one, it's behavior data. Like rather that we're not storing details, we're storing that someone has paid for something, and the other is the fact that we are not storing any card details. So PCI is when you store card numbers, but when you're dealing with a PSP or a payment service provider, they give you a token. So you could lose these tokens, and still they are responsible for storing the actual card numbers, and then the users, when they want to pay with a safe card, we assign that token to them, and then we have to ask them for the number on the back. And then we send that data, they encrypt it, like they're responsible for encrypting that data. We send it to the payment provider and say, this person's trying to pay, and we have this token saved against it. So it's your responsibility to validate. So we're actually PCI compliant because we don't deal with that information. But in this, it's just metric data. So if we share this, they won't know who's doing it. It's just overall behavior over the entire platform. Yeah.
What do you use for storing your metrics data?
Graphite.
Okay.
So it's statsd, and we push to Graphite into server, and it'll create buckets for each and every metric that they have.
I've heard that Graphite is quite hard to set up. Have you considered,
Well,
for example, Influx or
there are other APM tools like App Dynamics and can't remember the second one, but they're both competitors. And what they do is you install the box on the server, and it will generate all the metrics for you. But Graphite is open source. Well, that one you have to pay for the feature. But there are other tools that you can use. Graphite isn't traditionally very hard to write data to, but it's the setting up of the dashboards that is the difficult bit, because you have to understand what you're setting up and what dashboards you're interested in and what dashboards you aren't. So that's why you start very, very, very small, and you prove whether this actually makes sense to use or not. Okay, well, thank you very much. It's very enjoyable. I look forward to tonight's party.